Okay, hello everybody. This is Workgroup Device Management for September 16th. I can display the agenda. Here we go. So I wanted to just talk about one quick thing before we jump into this. And I wanted to ask, there were a few other things on future meeting agenda. I don't know if we'll have time for them, but I don't know if Eric is here or Praveen wants to talk about this or not. But if you do and you're on the call, add yourself to the end of today's agenda. And then the other thing I wanted to mention was I think there's a proposed 135 release schedule. I was just looking for it here. I haven't really reviewed this yet, but it's looking like at least what's proposed right now. We have, where is it? We have a production readiness freeze on October 9th, and that's going to be taken seriously this time, which means basically, those portions of your cap at least need to be done. And I haven't read what they wrote yet, but my assumption is they have to be done, not approved. I hope, because I don't want to have to approve things a week earlier than before. But enhancements freeze will be just the 16th of October, which is 1 month from today. So that's not a lot of time. And then we only have like 3 weeks between that and code freeze. So there's really compressed release. Just wanted to note that if anybody wants to comment on the release schedule, I'll put it in here.
When are they planning on merging that?
Looks like
I think the PR hasn't been.
No, I mean, this is live right now.
I went thought and checked. It had been merged, or something was merged. If you go to the
No, because I started. That's where I started.
Yeah. I had a discussion with Sig Release about the release directory being empty right now. So they they merged something, but not the README MD file. Oh, okay.
That's the actual schedule.
Yeah.
Okay.
I had a placeholder PR, or I had a PR with a placeholder that said that pointed to that pull request, and they decided to not merge that one. I thought they did that because the schedule had been finalized, but yeah, never mind.
It looks like
is it in 3 days?
Yeah, in a couple days. So if you've got complaints, now's the time to air them. I haven't looked. I tried in past cycles. I've tried to extend that code freeze the time between those two. I just don't know.
Is there ever going to be a release cycle, any of the three, where we actually have time for development? Just wondering.
We have to do the development
in parallel.
Pre-cap freeze.
Yeah. So it's sort of like, right, we have to get our cap work done way ahead. Okay. So that is the one announcement I wanted to make, so people are aware, and then we can jump in to Rita had a topic here. I can.
Hey. So basically, in the past few AI conformance meetings, in the working group meetings we've had, a lot of folks basically brought up the need for a DRA conformance program. I've started the thread on Slack, in the working group device management channel. I didn't see any volunteers, but I think it will be great to get some feedback from this group and see what we want to do next.
Well, we did talk about these in the AI conformance meeting a few weeks
Yeah.
ago, right? Is there,
The conclusion is for DRA specific things.
Mhm.
People thought it would be good to have a DRA conformance program because then it will follow the APIs and each, the vendors can work with the DRA maintainers, right? And then the AI conformance will point to the DRA conformance program.
So I think what we really need is we need somebody to take the initiative and drive this program. Like, so I guess there's 23 people on this call, and I hope that one of you might be willing to step up and try to run this program, and I can assist, and Rita can assist. Like I've been involved in the Kubernetes conformance for a long time. I can introduce you to people at the gateway. I know all those folks. So very willing to help and facilitate it, but I don't have the bandwidth to lead it myself. So I don't think Rita does either right now. So like if there's somebody on here, raise your hand now, approach us later. But like this is an opportunity to lead something that would be pretty visible and important to the project. So yeah, that's a call for help here. Anything else you wanted to say on that, Rita? Or
Yeah, do folks have specific questions about which requirement in the current AI conformance program that may be more suitable as part of the DRA conformance program? Do y'all need like an example or anything like that?
Yes, that would be helpful.
Okay. So for example, just this is fresh on my mind, but definitely not the only one. Like the device, like the hardware device version, is an example of consistency across the DRA drivers, whereby the conformance program will define some clear baselines to ensure DRA drivers are implementing these basic baselines, and therefore it would help users to know when they're using a conformant DRA driver, they're getting all the basic APIs implemented. John, do you have anything to add or another example that might be better than that one?
No, I mean, I think that's good. Like there's certain, I think, consistency across drivers we'd like to see. Things like version, things like product, things like model vendor would probably be useful to standardize. And I think there's some things in the AI conformance program about some of those things potentially being available, but you'd work in concert with that team to understand what the really specific needs are. Like, but the idea is that we can look at a driver and have certain expectations about it, and then other products, other ecosystem projects that are running on top of Kubernetes can have those expectations and be able to about discovery and whatever it may be that we come up with, but can have the expectations about what those drivers are and how they function and draw make decisions based upon that.
Yeah, I think, it's one thing to have a standard set of attributes, which is what I think you're kind of hinting at here. But another one is things like making sure that they actually leverage the device taints to advertise, or not advertise, but to mark a device as unhealthy, so that the scheduler can rely on that, so that external controllers can rely on that to view what the state of any of the devices are, as well as pushing that information to the other places where that health information should land, which is, like the resource claim status and or the pod status. Yeah, I see it more like the attributes is one thing. Like I think that's fairly straightforward. I think it's some of these other things that might be more controversial as to, we've got a whole laundry list of features that we keep adding to the array, and which one of those are essential to be considered conformant. I think that's the open question, at least in my mind. Because is to keep up with all of them, at least right now, probably just because everything's so new and in flux, is a big job. But I guess once some of them become more well established, it'll be hopefully become more clear. Which is why I think it's hard to say what is a must-have right now. Because in my mind, must-have is using device taints, for example, but that's still an alpha feature. So it can't really be a must-have yet,
Yeah.
right? It can only really be a must-have once that sub-feature becomes GA. Yeah.
Yeah, and I think there will be things similar like observability. We may want to come up with some like common metrics that we expect drivers to implement so that we can monitor them consistently. Things like, I mean, it's kind of going to be whoever's leading this is going to have to make the effort to help identify those things, working with everybody.
Yep. Sergey, you ever hand up?
Yeah, continuing on what you said, Kevin. I'm curious how deep we need to go with conformance, and like, do we need to test behavior when DRA driver can connect to kubelet, for instance? Is it part of a conformance, or it's part of a just regular like failure handling procedure, and everybody can do whatever they want? That's something that we also will need to figure out.
I think what you're getting at is there are sort of user-facing functional things, there are administrator-facing things, and then there are sort of just operational characteristics of the drivers, like that Kubernetes itself might want to rely on, and we could have to collect all of those, yeah, and identify.
And like how fast it registers resource slices, for instance, how fast it bootstraps. Is it like part of a conformance? Do we set a threshold, and after which it's not conformant any longer, or we should accept anybody? Yeah.
Okay, well, let's not spend more time on this. The call to action is like somebody to ask and answer all these questions, and kind of run the program, make it, put it together, make it happen, and would love to get some help on that.
And Rita, did I understand what you said is that this would become kind of a sub project underneath the overall AI conformance, so that AI conformance isn't necessarily responsible for figuring this out anymore? They would just point to this?
Yeah, you can think of it like that. It's a pointer. Yeah, but it wouldn't, I think it's still a sub project, probably under SIG Arch, because all the conformance programs are part of SIG Arch, but I definitely think DRA maintainers
Okay, I see.
need to be involved here. Yeah.
So
I
it's a
think so far the
spin-off of the AI
conversations aren't really
conformance.
moving forward because y'all are not in those conversations, and we also need to hear from the driver maintainers, right?
Yeah. Okay. Yeah. So it's more of a spin-off than than anything else. It's its own conformance program, is what you're getting.
Right. Yep.
Mhm.
Yeah, and again, just reiterate, I think there's a lot of value in making sure the driver implementers are part of the driving this conformance program, because they are the ones that's doing the implementation and can basically share feedback for particular APIs as well. So I think there's a lot of value in this program.
Yeah, that makes sense. All right, thank you, Rita. Okay, Geeta?
I don't think she's on the call, but this is just for us to ask how we can contribute to the workload aware scheduling KEP, since we're kind of relying on it for the multi-host hardware issue.
So, I mean, engaging with SIG scheduler, Eric is here. I think I saw he was on the list. He may want to chime in, but I'll just say, I mean, it's like any other CAP. We can engage with SIG scheduling. Eric will be the one probably driving a lot of the work, so he's the one to talk to. Eric, did you want to say anything?
I'm Eric Toon on Slack, and if you DM me, I'll try my best to get back. Comments in the doc which I'll put in the chat, or I think it's actually in the agenda as well, or I'll add it there, were welcome. and there's an issue, and then the reserved for issue. You know, I'm tracking that, so I'll respond to comments there. In terms of our alpha plans, our plans for alpha don't include fixing reserved for, but as soon as we have the new type added, like I'll certainly bring that to the attention of this group, and folks can start thinking about how that might work.
Okay, sounds good. So for the cap, it's mainly just like adding comments to the doc. In terms of feature development, do you kind of know how that would work?
I have a bit of a backlog, so if folks want to contribute, I can share suggestions on what to work on. I guess I kind of have a little bit of a sprint going with some of my coworkers, and I haven't figured out the how to get that open, which I should do, but maybe John and I can work on that.
Okay.
That sounds good. And also, Lee, so on the reserved for specifically, which kind of relates directly to this, to the DRA and APIs, Morton's been looking at that. So he's probably on the call too if you want to say anything, or you can reach out to him afterward if we want to try to progress that, because it's kind of more directly, well, they're all related. And so, in the interest of progress, right, we're starting on the workload aware scheduling, just getting this API in and getting the scheduler aware of the API. That doesn't necessarily mean the things we've talked about attaching resource claim templates to different levels in that work, or different groups in the workloads and different hierarchy levels like that. That might be a next step thing, but if there's any prep work we can do for it in the reserved for area, it might be useful, and we can think about Slack or something.
Okay.
About that.
Yeah, perfect.
I mean, the first step is to get this new resource into core, and then get it watched by the Kube schedulers informers, and then plugins like dynamic resources can start to look at it and do things with it. So we're a couple steps before dynamic resources plugin can use it, but when that happens, it'd be great to have prototyping of that.
Okay. Great. Thank you. Sounds good. We will reach out via Slack.
Okay, thank you. All right, Alea, are you here?
No. Yeah, so I wanted to discuss an issue we've run into. So in our drivers, the DRA driver, there is an attribute that for a new feature that we wanted to change that attribute. But before doing that, we wanted to make sure that folks are not relying on it. And because of that, an idea came by as a side effect of that discussion is should attributes be versioned as a public API, right? Because as DRA starts to get more and more usage, people will start relying on these attributes in terms of carving out their resource claims and resource claim templates. And more and more version upgrades of that driver and adding more features to driver could lead to the attributes changing over time. So I was just curious if folks have thoughts on this problem space. Basically, there would be two mechanisms to do this. One, we'll leave it on the driver to have some kind of a version field as an attribute in the list of attribute, and then evolve that as alpha, beta, and stable. The other would be that each individual attribute can itself have a version embedded within it along with the value. And then the benefit of that approach would be that in the cell expression, you can then say that I only want to bring in stable attributes in the cell expression, right? And ignore everything that is not stable. So I think that, we can discuss more on the approaches, but going back to the original question, do folks have opinions on whether this will be problematic or not?
Yeah, I see the problem. I suspect that there is no immediate good solution. Kubernetes itself hasn't figured that out for other string maps or string values either. If you look at some of the labels and attributes, annotations that have been introduced over time, I believe there are some GA features which still use labels that have beta in the name or alpha, because at some point they introduced that and then they couldn't change it anymore. We don't have in the API server any mechanism to remap attributes or to do versioning of attribute names, for example. It's just a name, it's just a string, and I'm not sure whether we have any ability to do something better in DRA attribute names, because it's not just the stability level of an attribute, it's also how do you actually transition from one name to another, which perhaps is the most common one, or how do you change the content depending on which attribute version an application expects.
I mean, I think the specific use case Ali is talking about was actually in removing one that we found to be problematic, and we don't want people relying on.
I think you just have to deprecate it in some version of your release, and then still provide it for long enough that you're sure that your workloads have been updated. I'm not sure, and perhaps have some tooling to check whether there are resource claims that still use it. It's very hand wavy. It would be nice to have something
that
better.
last part is really hard.
Yeah. So I think that to me this warrants a doc. Like, put a doc together. Let's start collaborating on it. There's a ton of different options. I think you've outlined a couple of them. We also have, remember the cell. We have in our cell expressions, like our selectors and things, it's a struct, and we can do things in the struct like you were saying, and say like, oh, this struct allows unstable attributes or something. Like we probably should get ahead of this and make something that works across different drivers rather than leaving it to every single driver to do it their own way. So I think it's a really on point topic. There's other similar things we're talking about evolving, like we've talked about, hey, for CPUs, it maps to more than one PCIe route. And so maybe we should be, if there's a cap or a cap issue that I put in to say, hey, let's make them lists. Well, now the type is changing. So the type could change, the value format could change. So like we should try to get ahead of it. Patrick, the cell team has some, don't they have some support for managing?
They have, but that depends. That's hard coded. You basically need to describe your cell environment, which fields are available, and for the abstract and opaque for Kubernetes attribute names, we should simply just have one field that says this is the map of attributes, and it's either available or it's not, and we don't have any way of versioning that.
Yeah,
the content of that map. It comes straight from the resource slice.
Yeah. Okay, so great point, Ale. No answers for you. So let's start that discussion in a doc probably, or you can create an issue and we can do it on an issue. I just find the docs easier to collaborate on.
Okay, sounds good.
Someone just shared a link in the chat.
Can you put it into the agenda so that we don't lose it? Because the chat, I guess, is.
I'll do that. Yeah.
Yeah, let's. So I see that. Yeah, Gaurav, I don't know that the comment Patrick made earlier, like putting it in the name, you still get locked to the name because all the manifests use the name. So putting it in the name is not necessarily sustainable.
That's true. That's true. But yes, without any other options, I think this is the best that you can do if you want to say something is unstable versus something is, well, stable enough. And so far, at least within the RNet, we have been assuming that, okay, attributes are very much a part of the API, and well,
Yeah.
it's not defined by the DRA API itself, it's defined by the DRA driver. So it is the DRA driver's responsibility that the API that you define is somewhat stable enough.
Right. I mean, we have the same thing that we can attach config raw extensions, right, to any claim or device class. And so those, it's up to the driver author to maintain some versioning on those, the contents of those raw extensions, and interpret older versions or whatever they need to do. So in that sense, we there is a sort of driver schema and driver schema versioning, but we don't offer the driver authors any help, and we might want to do that. Okay, so that was the last thing on our agenda, but we still have half an hour, and I know that Eric and Praveen and Sergey, this one's been on here a long time. I don't know if you want to talk about it. So are any of you open to talking about this now, or do we end early and next time we talk about it?
I don't have to go first, but I can show some slides to summarize the proposal around workload.
All right. First come, first serve, man. You raised your hand first. You get to go first.
Okay, Shais, you want to give me screen share, or I can send you the slides and project?
I'll give you a screen share. Give me 1 second. Let me just fix this. All right. Stop. Okay, you should be able to do it now.
Okay. Okay, I didn't get I presented this to SIG Apps. I didn't get a chance to customize it for you. I hope you don't mind. So you have it on the left, you have what I'll call a true workload. And there's like hundreds of these, although there's probably maybe 15 that are really important to Kubernetes users. And so it has a pod template or multiple pod templates. It's going to create a pod. Inside pod, we're going to add a field called spec.workload, which is a object reference to a same namespace object.
Sorry, Eric, can I just level set, because I don't know that everybody has the context of
yes,
what
please.
we're talking about. So basically, the general idea here is, right, we have the kube scheduler has always been pod by pod, match pod to node, match pod to node, match pod to node, and it doesn't think about, oh, this pod is part of a larger set, and that larger set has certain characteristics that need to happen. So the typical place we see this is we need all of these pods to start close together because they all need to intercommunicate. And so if we can't start all of them, we don't want to start any of them. That's what we're calling gang scheduling. And there's been a few implementations of this in the community over the years in different schedulers. And so Eric's been surveying all of those, talking to 1 million people, and trying to introduce a way to do this in Kubernetes scheduler. And then eventually we can layer in additional policy on top of this, like, hey, that group needs to be scheduled all in the same rack. Or when we schedule that group, we need to create a compute domain that group's going to share. Right, so that's kind of the big picture, but now Eric can talk about a little more of his specific thinking on how to implement or how to do this.
Like we have existing things that refer to groups of pods, like a PDB uses selector to refer to pods, topology spread constraints. You create a group by having a label selector, and then you make sure you set the same topology spread constraints on every pod. So it is possible to express like attributes to the scheduler or anybody about a group of pods only by putting in the pod templates, but it gets pretty messy, especially now we're seeing applications that want to have like multiple levels of topology, placement. You try to represent like a 3-level hierarchy just by this implicit information in pods, and it gets messy. There's no place to really track the status that's relevant to sets of pods. So you're kind of like, gosh, I wish I had a resource. And so then we started out with a proposal that was going to have a pod group resource. That's kind of what other ones do. And a pod group would just be a set of pods that need to be gang scheduled. But like looking more broadly, look at like leader worker set and job set are pretty popular now. They both can have multiple gangs. And so would want to be able to, we said it's better if we can match the resource to what the user thinks of as their workload. And so that's what this is. So here, instead of just having one gang group, like one gang scheduling set of pods, it can have a list of a set of pods here. In this case, we only used one because it's a stateful set. But if you had like a job set here on the right side under gang groups, you could have a list of different groups, each of which maybe independently needs to be gang scheduled. So if you read that conversation on issue 5194, DRA reserved for workloads, and I talk about pod group, that actually means one item in this list under the word gang groups on the right side. Any questions so far? Okay. So yeah.
I have a question. Sorry. Can you go back to that other slide? Well, actually, first, before I ask that question, have you presented this in other working groups as well? Like, working group batch typically is the place where these types of things are, like I've seen a couple different pod group proposals there that just kind of never went anywhere. I'm just curious if you've also presented it there, or are we only talking about it here for now?
There's a discussion of SIG scheduling, and I went to SIG apps earlier this week and kind of got a thumbs up from them. I'd say WG batch is a good idea. You guys were third on the list, and then I guess I'll have to add WG batch as well.
Yep, makes sense. Yeah, okay, so my question here is, so I guess I didn't understand the very last thing you said. So a pod has a new field called workload, and then it's referencing your workload object by name.
Yes.
And what does that mean exactly? Because yeah, I didn't follow that last part. How is that? Does this pod one instance of a pod that's part of that workload somehow?
Yes.
Okay.
So all pods will have 0 or 1 workloads they refer to, and all pods that refer to the same workload are part of that workload. Now, the workload itself can have multiple levels of internal structure of like hierarchy. Those are created by referencing with labels back from workload to the pods to segregate it. But the initial link, there must be a link from pod to workload. So the scheduler knows that either this pod has a workload or it doesn't have one. Otherwise, it won't. It might not observe pod and workload at the same time.
Yeah, I can see that. I guess the part I'm confused about then is, how does the pod know which gang group he's part of? And you might have just said it, but I didn't catch it.
So if there are multiple, then you have to provide a label selector that's for each gang group that says pods with this value are here. And we have to figure out how to make sure that they don't overlap.
Okay. So in the gang, what's that, John?
Eric said you got to make sure they don't overlap. So
we haven't decided whether we're going to allow distinct selectors and then runtime complain about overlap, or only allow a single label key and then each value and a value, they have to all use the same key but different values. So those are kind of the two things we have in mind. I need to go look at all workloads and see which one would be the most restrictive that still allows us to support all workloads.
Yeah, so I can see how you would stitch that together. And so a pod has a label. It says I'm part of this workload, and then the gang group it's part of says all pods that reference this workload that have this label are part of this gang group.
Yes.
Yeah.
And then so if you want more detail, the next level down is, this is not going to be an alpha. I'm just showing you what we're doing alpha. There'll be another thing which, we're arguing about names, but I call it a ranked group, which means the pods you can have subgroups of a gang which are indexed from 0 to n. So if you like have a gang scheduling, which is like 2 PyTorch jobs, and they each have, one has indices 1 to 0 to n, and one has 0 to m or whatever, you can represent that. And then when you want to do topology aware scheduling, you can even place things based on their index in an optimal fashion. Because sometimes you want the communication, if it's spread across like 2 smaller domains, to be organized in a certain way. So we'll convey that level of information. And then finally, we'll have enough information if you want to convey pod shape information optionally, so the scheduler can like be even more intelligent or make decisions earlier. We eventually want to convey that. So if you look at what's in the queue workload CRD, it's going to be pretty similar to that, except maybe a little more of a blank sheet design, hopefully more cleaner.
With the idea being that it's not bolted on top of the Kubernetes scheduler like Q does. It's actually integrated into it.
Yeah, it wouldn't prevent Q or Volcano from also using this type, but that is not a primary design goal. The design goal is that kube scheduler uses it for things that it can do, which is going to grow over time. And the reason it needs to grow over time is because dynamic resources is there, and putting it in core makes sure these different projects sync up better.
Yep. Okay, great. Yep, thanks. Antonio, you have your hand up.
Yeah, I have a question. Let me see if I understand. So a stateful set is like a generator of pods, and the workload object is like a scheduling controller for the pods. So my question is, did you foresee any situation that these separate objects deadlock and you need cross validation? I see gang groups min count 4. I'm saying maybe the stateful set is never going to be able to run all the replicas because the workload.
Kube scheduler will not validate what I call true workload object. It's up to the user and or in some custom admission controller and or the controllers to generate a right-hand side workload object that is correct. There's no validation by kube scheduler that those two match.
Okay.
Because today it doesn't look at the ones on the left-hand side. And one of our constraints is we're not going to look at them because there's too many and we don't want to watch 500 CDs. So that's how we would like this abstract base class.
Okay, you got my question. Because the other thing will be, I don't think that we have the API machinery for that. Thank you.
We don't. And so yeah, exactly. Okay, so step 1 is gang scheduling. We assess that is the most pressing thing, but we want to fast follow with some kind of topology aware scheduling. We envision that this is not firmly decided. I'm getting more into speculation. Probably the scheduler could provide support for 2 different types of topology aware. One is what Q and Volcano do, which is hierarchy of label oriented. And you use that when because people are familiar with it. And the second one that John and I have been talking about a lot, is okay to talk about this, John? Yeah, is that you could do it based on DRA resources that are multi-pod logical.
Yeah, multi-host logical devices is how I refer to it. We've talked about it in the past here. I actually have a doc I could probably share on how we would use the sharing we implemented with consumable capacity to enable this. I can split that out into an external doc and share it and get people's feedback on that.
One of the problems John and I were trying to solve was kind of the split between this label-based approach, which is easy to implement and everyone gets immediately, and the DRA approach, which is much more powerful and configurable, but is a little bit steeper learning curve. And so what we'd like to do is create something where you can use either. And you can grow from labels when you're like, oh, I actually need to tie some lifecycle to allocating a rack rather than just using a label for a rack. Then you can use a device that ties in the lifecycle. But we don't have agreement from the SIG scheduler to do step 2. This is already well into the vision portion. And then beyond that, one of the problems I want to solve is if you let's say you have a new inference architecture and look how fast this is, and you want everyone to try it. So you put it on, you put out a Helm chart for it, right? But today, there's like 5 different implementations of gang scheduling, and there's at least 2 or 3 implementations of topology aware scheduling, and that's going to be critical for people to get to try what you have. Do you want to tell people, well, you have to install this and you have to install this, and if your cloud provider doesn't have that, it's no portability of complex workload examples. So one of the motivations is to get a baseline in core that everyone can use to show how workload works. It's not going to exclude people from continuing to run Volcano or Q if those have new features, but it's, we're trying to level up the bar of what you can expect in every Kubernetes cluster. Beyond that, you can imagine re-implementing topology spread constraints or PDBs on this, and we want to think about fault tolerance. So like, how do you say I need a gang, but if a couple devices are dead out of 1,000, I still want to start. Buffering maybe could fit in there. And then there's a lot of discussion about resource reservations. We talked a lot about, should we do reservation or gang first? And we ended up with gang first, because you can do gang without reservations, or you can do gang using reservations. But if you have a reservation by itself, like, you still don't necessarily get a place to hang all this topology information. So does anyone want to know why we made a new type? I think that's probably pretty clear. I think Antonio's question kind of covered that. And then why is it a core type? Well, KubeScheduler needs to watch it, and I don't think we have the machine.
You're still going through slides, we've lost them.
Oh, okay.
Sharing.
I must have bumped something here. See him again?
Yep.
Okay. So yeah, why is it a new type? Because there's too many workload controllers to watch them all. And then why is it in core? Because there's not a way to have a CRD pre-installed, as far as I know, in a cluster. And there's not like CRD watch machinery inside of scheduler. And it's pretty complicated already. So core type is where we're at. And so then life cycles. We have imagined 4 different life cycles. The one that will work first, kind of at alpha, is what I call manifest life cycle. And that's where the user is responsible for creating the workload before they launch their actual workload, and then deleting it when they're done. And so the good thing about this is that it means that anybody can try this, even if their workload controller is not workload aware. But the downside is, if you look at, 505194, like, there's the life cycle at the end might be truncated. So I'm trying to figure out how we can like detect that the workload is idle even when the resource itself hasn't been deleted. Yeah, Kevin.
Yeah. So in general, I think this makes a lot of sense. Obviously, put something in core, have this notion of, this is called workload, and other people have attempted to create something called pod group. Like, it definitely makes a lot of sense to have this as like the baseline on top of which all these other schedulers could be built, all these other abstractions can be built, where the underlying primitive that they're built on top of is this notion of a workload. I guess where I'm hesitant is probably the wrong word, but I've seen a bunch of proposals for this over the years, and so I'm just curious what makes this one stand out as the one that hopefully will succeed compared to some of these others. So I think it might be good to revisit the history behind what people have tried and why, you see what I'm saying? Like, why this one stands out amongst those other proposals, and why we think that this time it'll succeed, whereas others have failed in the past.
So there's a background section in the doc where I compare all 5 existing solutions. But so if you want to get if you want me to see proof of work that I looked at the other ones, that's in the doc. But
okay, sure. I haven't seen the doc, I guess. Yeah, okay, that would help if I read that first.
But the quick answer is, answer 1 is that what's different about this is that it's not one pod group, and with like links between it, which is complex. We try to cover pretty much 95% of the cases of workloads with a multi-pod group object. And I would say there's been a lot of analysis on how exactly you would model existing workloads with this to make sure that it works with what I consider the important workloads. And then maybe just we bring in a good amount of energy from folks in my company and while keeping it open. So
yeah, I think there's probably a lot of momentum right now to get this right, whereas in the past it might not have been as urgent. So do you actually, based on something you just said, do you have an example of some type of workload that doesn't work that you've encountered?
I will say that I imagine that, so every field in this workload is going to be optional, and the more you specify, the more potential optimizations the scheduler can do. But if you just say there's a pod and it's a workload, this pod's part of a workload and I'm telling you nothing about it, that would be valid. It would allow you to do kubectl, like get workloads and kind of get, a mixed list. And maybe you can see how many pods are in each one of them. So you get a minimum amount of value. So in that sense, everything works. But what can you specify the least about? Well, if you think about like Argo deployment, cron job, it's kind of hard to model something which is like recurring over time. We put that out of scope. So instead of cron job, you'd want to model the jobs it starts, right? If you look at there was some Airflow operator implementations where it has a DAG of information about like what pods it wants to run, and that's hidden from Kubernetes. And so it just walks through its internal database and then launches pods, and the number and shape is like totally non-deterministic from Kubernetes standpoint. And we don't want to create a generic DAG type. So if you have like a very complex sequence of pod shapes you're going to make in quantities, you cannot model that. But if you have like a relatively regular quantity and shape of pods that's known a priori, then we can model that up to 4 levels in depth of hierarchy.
Do you, Eric?
Can you elastically scale them as well? I saw there was like a minimum number that you had at some point.
Right. So the minimum is used to like trigger gang scheduling to like unlock a group of pods. The idea we have a big idea, and I've been talking to people who worked on buffers APIs and stuff, that you could have a maximum, and then the scheduler could like try to prefer to find placements that will allow you to scale up to your maximum. If you ask for a huge maximum, then it'd be like, well, I can't find any place. But if you like are reasonable in your max request, it might try harder to find a place that has room for you to scale up. If you really want guarantee of scale up, we think the next step is something called reservation. Reservation will probably build on workload, except it'll have a longer lifetime than one workload. You could shove several workloads through it sequentially, with the downside that when the workloads are not in there, you're holding idle resources.
Sure. Yeah. Yeah. So in like the kind of common case where you, like you said, no a priori, these are the number of pods I want to schedule, you would just set minimum equal to the number that you're going to schedule. Exactly. And then it guarantees that all of those get scheduled somewhere before the whole thing actually gets applied.
Like we'll wait for a minimum to queue up and then we'll start them. And if, for the scheduler, if the workload controller decides to make one extra one, then there's kind of like it'll flow through immediately is how I imagine it's going to work. We're still working on the exact state machine, but like it's like, usually you don't want to do that if it's something that has a world size and it's not like Torch Elastic or something. Right. We're seeing in machine learning, you have got like MPI kind of classic stuff where the world size is totally fixed. And for those, min count is exactly your count. Right.
Yeah. Well, I'm picturing something like the MPI job. Like MPI job is the one I actually had in my head where you have a set of workers and you want to make sure that those are barriered and then they all start together and they're not going to grow or shrink. You just want to make sure that they all can land at the same time.
Yeah, and so the name min count is kind of unintuitive in that case, but min counting is going to be count in those case of those jobs.
Yeah. Yep, got it.
So Eric, are these expected to be or required to be homogeneously shaped pods in each gang?
No, you could. Okay. For the minimum requirement to be gang scheduled is to tell how many you'd like us to wait before we start you. But it would be permissible for them all to be different shapes. Now, we are going to, my vision, which is laid out, we have one called API Rev 1, which is in the doc, which says what we want to like GA based on what we're alphaing in 135. And there's one I call Rev N, which is like, we're trying to guess all the things we might want. So we kind of have a North Star to steer to. And in this Rev N North Star, there is a place that you can optionally list what I call the equivalence groups, which are like, I can say there's one pod in group leader that has this shape, and there's like, 15 pods in group worker, and they have this shape. And so to be in one of these equivalence groups, you have to have every property that is checked by the default filter plugins. That would be dynamic resources and node resources. I forget what it's called, but the two default filter plugins, they have to be identical for all of those, not necessarily for the scoring resources. So they could have two different images or something if you really wanted, or like they could have different downward APIs so that you can project the index through an environment variable that's necessary. But there's a shape equivalence concept that we want to bring in, and that state scheduling kind of has generally agreed makes sense.
Okay, thank you.
Do you have an example that shows how the resources are instantiated and how it integrates with DRA? What state or context is passed to prepare?
So I think that this doesn't directly, like later when we get to the multi-node resources, that's like an attachment to this. So it's kind of orthogonal to what Eric's talking about, or what he's talking about is like the workload object. And this slide is saying in the beginning, alpha users are going to be responsible for creating that workload object because we won't have touched any of the controllers yet. And then over time, there'll be like an adoption model where if the user created it, you can kind of the job can, or the workload controller can actually take it over and like manage it to some extent and garbage collect it. And it kind of goes through this thing. And when you get to the templated, I think there's a fifth one here, or it's a sub one of templated, which is like, could the user and the controller be like both partially responsible for creating the thing? So there's a lot more to figure out, but like the workload object is like a shadow, or the way I think I described it yesterday to somebody else was, if you've ever done SQL, it's like a materialized view, but it's a materialized view that's populated from many different tables, like a union select. So you're like, from I was an old SQL guy, so that's my way I think, right? Like you've got one query that queries the deployments table, or the stateful set table, one that queries the job table, one that queries the job set table, but they all end up with a view that's materialized as this workload object that is kind of a normalized abstraction of all those different controllers, and then the scheduler's logic is built on top of that normalized abstraction. So that's what this is about. At some point, what we'll do is we'll hang off of that normalized abstraction a resource claim template that says, hey, anytime this gang is created, instantiate a resource claim according to this resource claim template. And that gets us to the thing we were talking about the other day, Gita, of like, I want to create a compute domain at the time I deploy this gang of pods, and I want its life cycle when the workload that represents that gang of pods is destroyed, the compute domain is torn down as well. And like it gives us that life cycle of that multi-host object. But that's actually just glued on or referenced from the workload object. Is that?
I agree with everything John said. I'll try to be a little more concrete to Gita's question. In 1.35, what we want to alpha, the dynamic and as that progresses, that feature gate progresses to GA, the dynamic resources plugin will be unaware that the pods are part of a gang that's being gang scheduled, and it will do nothing special. As a follow-on, we would like in 136 at the soonest, ideally, we would like to start a new feature gate, which does topology aware, and potentially that could involve DRA. And we have to decide whether or not we would do 5194 concurrently with this or after this. And so I think that's a discussion.
5194, is that reserved for, or what is that?
Reserved for, yeah.
Okay.
Okay, so this becomes relevant for the multi-host user story when we get to this, what's been referred to as reservation or some sort of provisioning.
But before reservation's a different thing.
Reservation, we'll
Sure,
call
the
it topology-aware scheduling in workload.
Yeah.
We have to decide, will we do labels first, or will we do DRA first? We do them concurrently. And if we're doing concurrently, do we do pod only, or do we do workload in reserved for? And so I think it's definitely good to keep that workload in reserved for conversation going. Anyone that can read and digest what's in this proposal enough to like contribute to the 5194 would be great.
So I think from a sort of forward thinking point of view, like let's really target 136 to get integration between workload and reserved for and or topology aware scheduling. Like let's try to get some sort of alpha implementation of what we've been talking about in 136. I think that would be I'd really strongly support getting that as early as possible, but there's no way 135. We just have too short time cycle and too much to do.
It's even possible we could do 5194 in 136 without actually changing the algorithm of the scheduler to do better topology aware search. It could still be like, kind of, well, if you get lucky, you'll get placed well, but at least we'll go through the motions of using the life cycle around workload so something to think about.
Okay, we are out of time. But thank you, Eric. Thank you, everybody, for the great questions and discussion. And if you're interested in this, please sync up with Eric in Slack or on SIG Scheduling. Join the SIG Scheduling channel and talk about it there. So thanks, everybody. And we'll see you in a couple weeks.